Hi, I'm Alan. I just started MySQL this week.
Yeah, sure.
No. I've been using MySQL since 99, similar to 3.23 version. I've built large MySQL installations at LiveJournal, Community Connect, guyonline.com, and now 6apart, so LiveJournal again. I've been recently involved with some of this proxy stuff, so I'm going to try to give a quick introduction on this to say what it is and so forth. And if we have any questions, we can go from there. And then after that, I'm going to defer to Eric for the Q&A. Yeah, right. So is this supposed to work now? How far should I hold it? That's good? Okay, I'll try to not move. So who here is using a proxy for their database? Are you using MySQL Proxy? What are you using? Internal, okay. There's lots of internal proxies that people have made over the years, and even more so recently. Who here has heard of MySQL Proxy? Do you understand what it is? Have you played with it at all, seen it? Not so much. So, MySQL Proxies, it's pretty cool. It's Jan Konechke just, I guess, hacked this thing together over a weekend in February, where he uses the scripting language Lua for other projects, LightHBD, and decided to write another proxy to do, I guess, the same Lua stuff for MySQL. Uses the same generic architecture as Lighty, if you ever use that or you're familiar with that. So what this allows you to do now is you can now do any kind of crazy magic trick you've ever dreamed of or had a nightmare of that you could ever possibly want to do with MySQL, but couldn't ever get your head around the source code. This sits in between, like the nice Sequila operator here. It sits in between your MySQL client and your MySQL server, and it speaks MySQL. So you can use any client with it, your ODBC client, your Java connector client, your C client, your CLI client, whatever you want, it works. And then the proxy talks back to your MySQL server, pretending to be a client. That's about where the simplicity stops, and it starts getting kind of interesting. So I'm going to show, just to illustrate what this is. So basically, it's the proxy is written in C. The base protocol handler, all that wonderful stuff is written in C. And then there's the scripting language, which is Lua. It's very simple. Syntax is kind of similar to Python, if you used that before. It's a very, very fast, very small, very low memory usage scripting language. And honestly, I think it's a lot of fun. So I'm going to show a quick demo. If I can make this work, it'll be a small miracle. So I'm fired up here. I don't know if you can see this very well. The official MySQL proxy with a tutorial Lua script. Now this script, which I catted above this thing like an idiot. We don't need to see that far. It's pretty small. You can see just some basics in here. Function, read query, packet, if packet byte looks like a command query, then crap something out to the print, to the standard out. And then down at the bottom, you see the read query result. So when a query is coming in to the MySQL proxy, it'll fire off both of these functions at some point during the execution. When the query's read and when the query result's read, and then it'll print a nice little timeout. If you ever use MySQL's slow log presently, you'll notice that you only have a resolution of about 1 second. So if you have a query that takes 300 milliseconds, that still sucks, but you'll never know. Something like a proxy in its most basic usage is very useful if you want to, say, put this in front of your development environment and say, I guess, track down and yell at any developer who writes a query that takes longer than 30 milliseconds, 100 milliseconds, 300 milliseconds. You can profile large queries, small queries. In the more advanced usages, you can run other commands around this. Like If you wanted to look at the state of the server before the query runs and then the state of the server after the query runs, you can add this all in very simple Lua scripting. I'm going to connect to the proxy here, and you can see down in the corner it printed out some crap. Query time, show databases. When you connect with the MySQL CLI client, it'll run a few queries just so it can bring you to this nice prompt. You see a show databases, a show tables, a nice select version comment. You can see those took an amount of time. If my laptop weren't underclocked right now, it'd probably be a little quicker. So I could run queries there all day, but something a little more interesting is this window here. I'm now talking to the proxy, but not to the MySQL server. So the proxy itself has an admin protocol. You can run administrative commands. You can change the configuration. Let's see if I can remember the query here. So this proxy config table does not exist in my MySQL server that's running here. In fact, the server version that popped up is not my MySQL server. That's 5.0.45. This one is reporting 5.1.20 agent enterprise MySQL something. That's not me. So with this, you see that the proxy is something you can modify, you can play with, you can write administrative tools with. You could have a database without ever having the database, if you were so inclined. And I don't know any other. I didn't have enough time to prepare any other cool commands from there or any other demo. So the other thing I'm going to show real quick is I wrote my own proxy. This is a long story, which I won't actually tell. But when the MySQL proxy was first developed, it was not free. It was not open source. It was not available. You couldn't download it unless you were an enterprise customer. So I talked with Jan, and he kind of encouraged me to actually give a shot at writing my own. So I tried that.
Now you're using MySQL Proxies.
Well, I want to use both. I mean, mine is actually when the official MySQL proxy did eventually come out with the source code. There are some very, I guess, subtle architectural differences. Mine might actually scale better. So if you wanted to, if you wanted to put a proxy in front of your giant, massive production database, and then pull your connections down, so you only have as many backend connections as you need, but you could have 10,000 clients connected to MySQL. But the only backend connections that are ever used are ones that are actually running queries. So if you have, say, a huge amount of clients, or you want to restrict what queries can run on your backend based on how big a query is, how long a query it is, a historic profile of a query, or if it's an administrative connection, you always want to let something get through, or a heartbeat, or anything at all, you could do whatever you want to restrict that. So I'm going to fire up my default demo here, creates a backend, talks to the server, okay, I'm great, I'm fine, I'm happy. Now I'm going to connect to my proxy with a little shell wrapper. So this is connected to my proxy. It claims to be 5.0.37. My server is 5.0.45, I think. I used to have a clever string in there, but I took it out. So here's a fun little demo. The default demo for my proxy is a connection pooler. Very, very basic implementation of what I just described. So we show here, we have one connection under show process list. And I won't do that yet. And over here, we have another connection. So the proxy is handling the other connection that comes in. It says hello to the back end. It runs the queries against the back end. And I can't spell. Now over here, we still have one connection when you do a show process list. Go back over here, one connection. These are both connected to the same MySQL database, just going through the proxy. If I use my test database over here, and show tables over here, you can see that the session is shared. I wanted to have a much cooler demo ready, but I decided to play video games this weekend instead of finishing up the code. Go ahead.
How does the connection pooling handle things like transactions and session variables?
So this demo doesn't at all. What I was thinking for the more fleshed out demo, of if you're running a real connection pooler, you would want to, in the MySQL protocol, you can detect if a transaction has started. So at that point in time, you can say, this backend connection has a transaction running on it. Just ignore it until the transaction's done. Pull it out of the pool. Don't let anybody else use it. As far as session variables, there's different ways. You can try to parse out if somebody's using a session variable, or you can just tell them to not use it. If you're designing for use with a connection pooler, you have to kind of keep that in mind. There are ways around it, and it'll probably get easier as time goes on. And people write libraries for these things to detect if you need to recycle a connection or not. Go ahead.
Just a simple way of doing that might be to implicitly create a session variable under a private namespace, which is the IP address and the client port of the actual client.
Yeah, I mean, you can localize the variables in any way you want. You could do crazy tricks with sharing variables, all kinds of crazy nastiness that you probably don't actually want to do. In most cases, what you'll want to do with if you're just trying to implement a basic connection pooling is if somebody does something that dirties your connection, you can detect that. You probably just want to reconnect later, or drop the connection, or mark it as dirty, or lock it to that one connection. But you can certainly run transactions through this. You can run any kind of query through it at all and interact with it. I guess I have one more thing actually. Oh. So that's obviously not real SQL. The other part of my demo that I had working is just very, very simple query rewriting. When I get the hello command, I just rewrote it to select 1 + 1. So you could write basically anything into your SQL and have it be commands for your proxy. You can write comments into your SQL and parse that out and then have that be something significant. Like I could say, one example that I would use with connection pooling is I'm looking, if I'm using connection pooling, I obviously want to keep pretty good control of what's going to my backend. So if by default I could have queries that take longer than a second automatically be killed if they're selects. So the proxy would have an internal timer that says, okay, you've been going for a second, die. But I might have this other query that might take a couple seconds occasionally that a cron runs. And so I'd have a comment in there that would say the max time that this query can run is 15 seconds. And so the proxy would use that instead and then kill the query after 15 seconds.
Are you using the comment format, the executable comment format in MySQL for that?
I guess so.
/*
Yeah.
bang version number.
Yeah.
How does that work with your base version number versus the version number of the server thing that you're actually running through?
It never gets there.
Okay.
So I'm the first one to look at the comment, and you usually strip it out, or you can rewrite. I haven't actually played with this too much. I just did a straight up comment, /* whatever.
Yeah.
So there's no version number in there. It's just a comment. But you could prefix it with something that gets rewritten before you pass it back to the server. So that's most of what I had for the fun little demo.
This proxy, is it compiled into the server? Or can it live on a separate proxy? Doesn't it?
Completely separate.
Completely separate.
Completely separate. It's just a separate small C application that uses libevent and Lua embedded. The question was, is it a separate process? Is it built, or is it built into the server? One of the things I wanted to try doing in the future was actually slowly move it towards being embedded in the server. So one thing you can do now is if you wanted to run the proxy to control your connections, but don't want to add, you do obviously have to do TCP on either ends of it, which adds a little bit of latency. But you could say run MySQL proxy on the same machine with MySQL and then connect over Unix domain sockets. And later on in development, we could play around with adding it as a plugin to MySQL that just listens on a different port and talks MySQL and speaks its own protocol, but proxies stuff internally as its own thread in MySQL. That's it.
You said earlier that your architecture was a little bit different than MySQL Proxies. How is it different?
So MySQL Proxy is actually usable. Mine is a hairy mess. I'll just give you an idea. So,
Is yours like a multiplex statement? Where there's
no, it's actually the same architecture. We both use libevent. We both use Lua in one thread, one process. But the way I do, in one of the best ways to show this is this is my default here. This is my demo. You can see it's doing all kinds of stuff. Fires off a backend. It's got the listener listed. It has create a new backend, and then up there you can see it says function server handshake. You're actually getting a handshake packet and performing part of the authentication inside Lua. So what mine does, what the official one does, is it wraps up everything into nice, fancy little C libraries that make it easy for you to write queries from the proxy. It makes it easy for you to connect something. You just say, I want to connect to the proxy. I want to connect to my backend server. I'm going to get a connection. I'm going to do this. I'm going to do that. And it just works. With mine, every single packet is wrapped up into a Lua object and sent up. So in the MySQL protocol, when you connect to a server, the server sends you a handshake packet. And then you respond to that with an authentication packet. And then it responds to that with an OK packet. In the official proxy, you don't see any of that. In mine, you actually get those packets as somewhat easy to use Lua objects. And then you can rewrite any of the fields inside that packet. Now, obviously, I'm going to make it a little easier to use by actually writing Lua libraries that wrap this stuff so you don't have to play with it. But it means that for my proxy, you have a much lower level access to all this junk. And you can pre-allocate packets. You can store packets in a wire format. And you can implement a lot of the features that the official MySQL proxy is implemented in C in pure Lua with mine, and it's still the same speed or faster. Any questions?
So have you benchmarked this against the MySQL Proxy?
No. I've not. I have, I don't know if this demo is going to work with it right now. So one of the things I did is I wrote I've done exactly one optimization with the architecture so far to speed it up a little bit. And this is, of course, just running on my laptop here, which is on its battery and is underclocked. So this table, the select star from blah, this table is about 9 million rows, 8 million rows. And every single row that gets sent from MySQL Server to your client comes as a separate packet. And these each have to be handled independently in the proxy. So with mine, I got this uncached query back in about 10 seconds. The cached one should come back in about 6 seconds, I think. Before my optimization, this took an order of about 20 seconds. So it was a pretty significant overhead. About 6.5. Without the proxy in here at all, this query takes about 5 seconds, 5-6 seconds. So you can see it's adding, even on the same machine, and I'm not binding anything to different CPUs or doing any other optimization. It's adding very, very little overhead, even with going TCP/IP to the client and then to the proxy from the client and from the proxy to the back end. I've designed it as a streaming architecture, so it'll stream result sets back and forth. You don't have to buffer an entire query up. The official proxy, if you're modifying a query, as far as I can tell, you have to buffer the whole thing. So if I were to run this query against the official MySQL proxy and then change something at all, and then send it back, you have to wait for it to buffer up entirely, and then wait for it to send from the proxy to your client before you can do anything. So that adds a lot of latency. I've done a little other work about being able to stream actual packets. So if you have an incomplete packet that's traversing through the server and you don't want to do anything with it, you can just go straight on through, add almost no latency at all. So the goal of mine is to be able to get it to scale to the point where you can run it in production. I'm not sure if that's really the goal for the official proxy yet. We hope so. It'll probably get there eventually. I'm sure Jan could do it in 20 minutes. It'll take me 3 weeks to get anything of the sort. But this is pretty cool so far. I mean, this is basically trash.
So
What I've wrote.
scripting language, you actually pass every row into some kind of function to intercept that, or how does the streaming work on the internet?
So the streaming works, every single packet that comes into the server, for every single packet that comes into the server, I'm not going to bother bringing up the code. What happens is, as the packet comes in, and then internally in the protocol, there are different states of what your connection can be in. You can be waiting for a new command packet. You can be expecting a field packet describing your results. You could be writing a row packet or any of that low-level stuff. So there's a state transition, and then there's a data packet. And then when you're writing your Lua code for MyProxy, you register callbacks based on the transition. So if you only want to look at command packets, you set a callback on new command packet. And then as the packets come in, the proxy will check to see if you're waiting for a new command packet. And if you're not waiting for it, it'll just blindly pass it on. If you are waiting for it, it calls up into Lua and wraps the object and then wraps the packet in a thin object, and then gives that to you to do something with. So the idea there is if you only want to listen on one part, or if you're only listening to certain parts, or you can enable or disable certain callbacks, if you don't have a callback at all, then it might as well have not ever touched the proxy. It'll just go straight through. Anyone else? Architecture questions? Anything really confusing? Why would you ever use this? This is weird. Not so far? Not so much? I don't know about production. I know I know Jan is using it obviously for consulting users of MySQL. The official one is very helpful for profiling queries or plugging into an environment which is somewhat low usage but is having a performance problem. It'll just pick out your bad query just like that. So I know some consultants who are using it that way, but I'm not using it in production anywhere yet. Six Apart is actually pretty interested in using mine in production, so we'll see how that goes once there are multiple billions of queries going through it every day. But no, not yet. Any other questions, comments? Not so much. Okay, that's all I have, I guess. I'll defer to Eric for the rest. The Q&A.
Test.
What Alan did, or were we clapping Eric?
No, you're definitely not clapping because I came up here. We have about, I don't know, 45 minutes or so to kill. Does anyone have any general questions? Problems that you have? I know. Jeremy's much better at this than I am. Problems you're having with MySQL? Yes, in the back.
So, I've been working with MySQL a lot more in the last few weeks than I ever have before. And I keep running into some stuff like that. So one of those, what I'd love to know if anyone has any suggestions for, is you have a production MySQL server. It's already running. You can't shut it down. You can't stop it. You can't do anything like that. And you want to be able to see what queries are in it.
Do you have the slow query log enabled?
Well, let's say that they're not slow.
Okay.
They're less than a second.
I have a script that does a show process criteria. It's
Yeah.
not beautiful.
But the problem there is it's a snapshot. I'd really love to see.
Natural.
Yeah, like if I could find something where I could take a TCP dump
Yeah.
and turn
Use
this
the
into,
proxy. Put the proxy in front of your server and turn on logging.
but I'd have to switch
Take
courses
out
around
the-
and take it down.
You have to take it down, you tell your client to
So,
connect to you guys.
so yeah, the question was, how do you get basically a stream of queries running out of a MySQL server that's already going in production? The easy answer is that you really can't. You can actually use Ethereal or Tethereal and actually parse the queries out of it. Tethereal will spit out syntax that's very easy to parse and very easy to log. I wouldn't necessarily turn that on a production server and just let it stream to a file because it'll fill up really, really fast. But
ideas for something where you're actively talking to people?
Yeah, MySQL itself doesn't have anything built in for that. You have to basically hook into it by hand. So yeah, the general log is one suggestion, but you can't enable that without restarting until 5.1 something, I believe. So that's a good question. What's that?
5.1,
How is it? The question is, how is 5.1? Not ready yet for production. It's getting really close. They're still having some issues with partitioning and other things, but it's gotten a lot stabler over the past few months. If you're starting development now on something that's going to be released into production 8 months to a year from now, 5.1's a pretty good option for that. I wouldn't plan on putting it in production right now.
So how can you partition with 5?
With 5? Partitioning inside of MySQL, or like Jeremy usually talks about, partitioning above MySQL? Okay. There's two different types of partitioning. There's partitioning within one single instance of MySQL. So if you have something like logs coming in, and say every month you want those logs to rotate into a new table so that 2 years from now you can drop a month's worth of logs, that's actually built into 5.1, and that's MySQL's official partitioning support. The other kind of partitioning, and the one that usually comes up, is partitioning above multiple instances of MySQL. So say you have a user database with 1 million users in it, but you can't get one instance of MySQL to run fast enough to support all of those users. So you might put, users A through H on one MySQL server, and so on throughout the alphabet. The higher level above MySQL partitioning isn't supported by MySQL. It's something you have to do in an external library or project such as HiveDB. Yeah, which kind do you want? Okay.
What is the best hardware one recommends for high write database and comparative frequently?
We've been using Dell 2950s with 8 15K SAS disks. That's with 16 gigs of RAM. That seems to be about the best configuration of price versus performance. Those are about $6,000 a piece. So once you scale beyond what one machine can do, you partition across multiple machines. So, and then always have a backup in there. So one partition would consist of 2 different machines. So.
Do you have any MySQL cluster experience you can share?
Not really, and I can explain why. Do I have any MySQL cluster experience? And that's referring to the NDB cluster storage engine in MySQL. I really don't, because I don't have any customers that have a workload that really requires that. Cluster's built for relatively small databases that can live in memory on 4 to 8 machines and update really, really fast. It was originally designed for working in cell phone switching towers. So if you picture a cell phone in an area of like 30 miles or so, all of the cars and people coming in and out and updating every time they do. So there's not a lot of people that have that kind of workload.
So if that is the case, how do you ensure high availability without clustering?
There's basically 2 methods for that right now. If you look on MySQL.com, you'll hear a lot about DRBD, which is a replicated block device between 2 machines. I don't really recommend that, and I can explain why. The method that I use is the dual master. So you basically have 2 masters set up. Your application's writing to one. If that one dies, you fail over to the second one. So
you have to, somebody has to manually fail over the second one?
I recommend manual failover. There's some people that are doing it with Heartbeat right now. The problem with Heartbeat is it likes to fail over when it's not supposed to, so it'll flap a lot. It causes all kinds of problems. So typically, if you're big enough to have an operations team or someone listening on the pager, and they can be in within 5 to 10 minutes, look at the system, see what's wrong, and make the decision to fail over, it works a lot better. So, back.
So this is more of a strategy than a technical question. I don't know
Okay.
how familiar you are with MySQL's business strategy.
Some.
Oh, okay. So anybody know what MySQL's sort of long-term plan is to work around the Oracle acquisition of InnoDB?
Falcon. Falcon is a storage engine written by Jim Starkey. It's supposed to replace InnoDB as the ACID-compliant OLTP storage engine. There's also another company called SolidDB that's local to this area, and I don't think anyone's here. They've built an embedded storage engine for years and years, and they're now turning that into a storage engine into MySQL. So they'll basically be Falcon, Solid, and InnoDB fighting it out to see who's going to be the best. As far as the Oracle acquisition goes, Oracle's still pushing a lot of really great updates into InnoDB. They don't seem to have any plans to stop anytime soon. So, I still recommend that to my customers because it's going to be a year or two before Falcon's close to being stable enough to run into production. So, if you're deploying something now, within 6 months or a year, stick with InnoDB.
Any experience on data warehousing with MySQL?
Not too much. Jeremy would be better for that question. So the question was, do I have any experience with data warehousing? Jeremy would be the person to ask. I do more monitoring operations and capacity planning for OLTP sites. So
in your experience, how often the 5.0 version of MySQL has crashed?
so the question was, how many times have I seen 5.0 crash? The last 3 times I saw it crash, it's because it was running on top of DRBD. So it wasn't actually MySQL's fault. So it was customers that had a pair of masters set up. DRBD was replicating the block device between both of them. The first instance, the master crashed. DRBD sent something across that caused the secondary to crash. The last 2 instances, DRBD replicated file system corruption across. So.
What's the latest in terms of consistency checking technology? When I was using MySQL last week, we were still using ISAM, and when you have very, very large databases, and you have MySQL crash or something like that, or worse, a host crash, my ISAM check is probably not your fastest. Well, it is the only way to get back up.
Right.
Now in terms of checkpoint and whatnot.
If you're using MySQL in production or in a situation where if it crashes and it has to come back up within a few minutes, don't use MySAM, use InnoDB. So,
Is it better at handling?
yeah, it keeps everything consistent on disk always. If the machine crashes, unless the file system was corrupted, it'll come back up.
Does it use ODirect or OFCTP?
It's optional. I usually use ODirect on Linux.
Is it reliable?
Yeah.
Okay.
You can walk up to a machine with InnoDB as long as the write caching is configured correctly, pull the cord on it, it'll come right back up. Yeah.
Okay.
So actually the backup strategy that I use involves checkpointing the file system underneath InnoDB. It's been solid for years. So
Just the same
using LVM, taking an LVM snapshot of the file system and then just backing that up. So, which is essentially to InnoDB is the same thing as just shutting the power off. So.
In terms of speed, is MySQL better than InnoDB?
It depends. So the question was, in terms of speed, which is better, MySQL or InnoDB? That gets down to the internals of each engine and the type of tables that you're actually building with them. Quick example is InnoDB can actually be faster for primary key lookups, so where you're selecting where something equals a primary key value. The reason for that is InnoDB stores the row data with the primary key, so as soon as it walks down the tree, there's one seek to grab all the row data. MySQL typically faster for secondary key lookups, but it depends. InnoDB has row-level locking, so it'll commit transactions and handle concurrent updates a lot better. So that's the 5-minute summary. There's really a lot more involved in it, so it depends. Again, if you're running something in production where if the box dies, it has to come back up, just run InnoDB, take the performance hit, buy an extra machine, it'll save you in the long run. So, questions? More questions?
When was the last MySQL conference?
End of June, April. beginning of June, beginning of May. Yeah, it was fun. It was. We did kind of an extension of the same session that we did the year before. So this is more about partitioning versus the actual failover stuff. So I think we have that tutorial session blocked out for the next 10 years. So we'll be there again next year.
If I were to go for MySQL master slave replication, let's say East Coast to West Coast, how can I make it faster?
The question is, if you're replicating MySQL from, say, the East Coast to the West Coast, how to make it faster? The easy answer is to speed up the speed of light. The master, once it receives a query and it's processing it, it tries to push those updates out to the slave as fast as possible. So the latency between two master and a slave is as fast as the network can write it. So the bottleneck in that system is usually how fast the slave can pick up those events and apply them to its own tables. So I don't know, latency across the country is what, like 80 milliseconds, something like that. So I don't know, unless you're on a really, really slow connection, it's usually not an issue. So the slave will usually fall behind applying those updates before the master will fall behind sending them. So yeah, Chicago or Dallas. Yeah. Yeah, it's really how fast the network can actually shuttle all those packets across. So.
I have more kind of like a SQL question.
Okay.
So, what is the best way to implement tags? Like, I mean, in Pandora, I mean, the music, you have piece of music have some tags on it. So, I mean, what is the best way to implement it?
To implement tags?
Yeah.
That's a tough question.
Tag.
I don't know. Jeremy's going to have a better answer for whatever I come up with. So the basic problem behind that is that tags are a graph structure, and MySQL is all implemented using trees. So you're basically translating one data structure into another, which is never that fast. So there's a big hole in the industry right now for how to implement that really efficiently. As far as I know right now, people just build a tags table and a relations table and then cache the crap out of it with memcache. So Rick might have some better ideas. That's what I've seen. So hopefully soon someone will come out with a storage engine or a patch that will handle graphs and social networks a lot better. So. Questions? Anyone else?
I have a query. If there's a summing of, like, it has around 20 columns, and it goes summing across all the rows, and it sums around like 10 million rows. But the time it takes, which I don't see any IO load as well as no CPU load. The query consistently takes around 70 to 75 seconds.
So the question was, why is summing and group by so slow? That's actually partly due to how MySQL handles group by and handles temporary tables. As it's reading through and resolving a group by query, it's actually unpacking and packing that row data multiple times, both out of the table that you're reading it from and into the temporary table that MySQL is using to store results. Watch Jeremy's blog, because I think he's going to patch that within the next week or so. So hopefully we fix that.
Indexed by what you're grouping by, if the data is ordered that way, wouldn't it optimize in some fashion?
For min and max, but not really for sum, because it has to read all the rows anyways. So min and max group by will read either end of the index. So, yeah, the major overhead is reading in and out of the temporary table and repacking those rows. So
How could Jeremy improve that?
He's going to build a hash table, which essentially acts as a cache in front of the heap storage engine. So instead of repacking those rows every time, he's going to keep an LRU of 128 or so entries of the most commonly used ones. So instead of repacking those rows, you just update the hash table.
No, I thought it already did that.
It doesn't. It should. So. Questions? What time is it?
Another comment on the summing up.
Mm-hmm.
If you're doing this a lot and it's over historic data, keep summary tables so you don't have to go through the millions of rows, but merely go through the current data.
No, that is definitely an option, but we as the last resort, like you can have some as a batch activity, you just populate the summary table.
Yeah, cache it.
So do you have any experience of caching the table in the memory to make the read and write go faster?
Yes, MySQL will do that internally for InnoDB tables in the buffer pool. Depending on your workload, you can probably benefit by sticking Memcache or a Memcache cluster on a different set of servers and caching it there. Memcache will be a lot more efficient than MySQL at caching just simple key value lookups.
If you have a cluster of servers, then you can.
You can. You can actually cluster Memcache. So it'll do,
It will invalidate the rows.
yeah, you have to do the invalidation in Memcache yourself, but as far as it can broadcast updates and it'll partition across, most of the client APIs will partition across multiple Memcache servers.
It does so extremely well.
Yeah, it's really fast.
incredible piece of software.
Questions?
So I have a table which is of MySQL,
Uh-huh.
and I want to change to InnoDB.
Okay.
So what are the consequences of this is a production?
So the question was how to change a table from ISAM to InnoDB. The actual changing is really easy, just alter table. Your application has to be smart enough to deal with transactions that were rolled back due to deadlock. And what else? What am I forgetting, Rick? I think that's the main one.
Hard keys will go away. So
Yeah.
no problem.
Yeah, I think the main one is that transactions can be rolled back due to deadlock. Internally, InnoDB keeps locks on rows. So if you have a connection A that locks, row A on a table, connection B locks row B, and then they try to lock each other's rows, it'll deadlock. InnoDB will detect that automatically and roll back what it thinks is the smallest transaction. So instead of getting OK back in your application, you'll get transaction was rolled back due to deadlock, and then you just have to retry. So, and that can appear what looks like randomly, but so.
So does that mean I don't have to worry about deadlock at all?
You do. With MySAM, you don't. With InnoDB, you do. MySAM only locks tables, and it locks them in a predefined order. So, two threads can race and lock a bunch of tables, but they can't lock a table that someone else has already locked. So, there's no deadlocks with MySAM. So,
Also, when you convert from NODB, you can't remove the space that you have
right.
in the table space.
That's a good point.
In NODB, you've got this table space that will only grow, it never shrinks. If you take the table out of there, well, you've got empty space in there, but your disk file that doesn't shrink.
All right. It won't shrink. The only way it'll shrink is if you're using an InnoDB file per table, in which case newly created tables will get created in their own table space file, and if you drop the table, that'll go away. But if you're using just the regular global table space, InnoDB will never shrink that file. You have to dump everything out, shut the server down, delete those files, start it back up, and import everything again.
But as the table space grows, eventually that data space will be reclaimed.
Yeah, it will. It'll be reclaimed. Depending on what happens, that can take a long time. So, it's also a good point. Yeah, one thing to note about that is alter table. Since alter table always creates the new table as a temporary table of the correct storage engine type, if you have one table in NLDB and you alter it, your table space will grow, a little bit less than twice as big. So, which can be surprising. So. More questions?
how can you have a, like I'm using a MySQL table
Mm-hmm.
and I'm doing an insert read and other connection I'm trying to read the data set. So the data set I get doesn't have a consistent result. So basically what I'm looking is I want a consistent read snapshot. How do I achieve that?
So the question was how to get a consistent snapshot out of MySAM when inserts are running. Are you using concurrent inserts in MySAM? The point of concurrent inserts in MySAM is that inserts can be happening and not interrupt other selects because there's no real concept of row locking. The only way they can do that is to always append the new data on the end of the file and then not let the new rows be visible to existing connections until all of the index updates and everything are done. So I guess the answer is you really can't.
Block tables, right?
Yeah. Yeah, you can block everyone else out. You can turn off concurrent inserts. If you want to be able to have that kind of control over consistency in views, I would say use NODB because you can leave everyone as read committed or repeatable read, and then if you have a connection that you want to use to spy on someone else's transaction, you can set it to read uncommitted and see what they're doing. There's not a whole lot of control there, yeah, except for locking tables.
You could presumably do lock, snapshot, and lock in very, very short order
Yeah.
if you've got a decent file system.
Yeah. I mean, you mean like consistent for backups or consistent for other connections?
Consistent for other connections.
Yeah, changing the insert concurrent. I just lost my train of thought.
The result we went to InnoDB to MySQL.
Uh-huh.
The speed of insert. With InnoDB we find the inserts were taking order of minutes.
Okay.
With MySQL we find it.
There's actually a really great page of the manual on the speed of insert queries. The main thing with NODB is to buffer them as much as possible. So if you're using auto commit or you're committing after every single insert, it's going to be really slow. So you have to batch, up to 10,000 rows or so in a single commit, and you'll be able to insert probably almost as fast as MySAM, but not quite. So it shouldn't be an order of magnitude difference like you're saying, though.
MySAM also greatly benefits from doing multiple rows in one insert
Yeah.
statement.
Yeah. Both of them have optimizations for inserting. Both those optimizations deal with inserting multiple rows at the same time. NODB buffers secondary index updates. MySAM waits to flush the indexes until the inserts are done or the table's unlocked. So it depends. Come talk to me afterwards and we can get more into it. But
When you put multiple insert into one statement, what is the practical limit of how many you put there?
Depends on how big the inserts are. I would say if you're bulk loading data, it's safe to stay around 10,000 rows or so. Internally, when you do alter table, that's the number that MySQL picked for alter table. It depends.
What happens, a good way to think about it is what happens when you do a restore, like from MySQL cloud.
Mm-hmm.
Because that's designed to be as fast as possible.
Yeah, but it's still not that fast.
There's also a net buffer length or something.
Yeah.
Like 8 megabytes. So if your insert statement is bigger than that, you'll croak just trying to.
Right, so actually, yeah, I found a bug in that the other day. So MySQL dump, when you create a dump file, it reads max allowed packet and then tries to create the dump file for that max allowed packet. It accepts that as a parameter on the command line. So if you want to dump like 1 gig rows, like if you're storing huge blobs in rows, you say max allowed packet 2 gigs, and it'll write that out to the file, but it never writes the max allowed packet parameter in the dump, so when you try to import it, it pukes. So, yeah, I'll hopefully fix that this week or next week.
Maybe that's intentional, or no one does it.
That's a good point.
Or at least if they don't know what they're doing, they'll find that later.
Yeah.
But it sort of implies you can never use a long blob. Medium blob is about all you can ever.
Exactly. So yeah, the defaults are only built to handle like medium blobs. More Questions?
Any particular experience on NT3000?
On what?
NT3000?
I don't know what that is.
Oh, that's Dell storage.
Dell storage. Oh, the external RAID arrays. So, question was, do I have any experience with the MD3000s or the I forget what Yahoo used to have.
I mean, the question is like what RAID level one recommends and what is the string size?
That's another great Jeremy question. RAID level, typically RAID 10. Stripe size, I don't know. Jeremy has that on his blog. He does most of the system level benchmarking stuff, so I don't.
You said there's a maximum striping beyond which it's unpractical?
Yes. Yeah.
Anything above or below gets kind of weird.
Say again, please.
64K is usually the default, and it turns out it's apparently the default for a reason.
Yeah, it's going to be somewhere within an order of magnitude of the NODB page file or page size, which is 16K. So yeah, 64K, perfect. So. Questions? Anyone else want to take questions?
Only if you want wrong answers.
I can take low-fast memcache questions.
That's great. Yeah.
And work the
Memcache is a great topic that I haven't dealt with that much. So,
memcache questions.
actually, what does anyone know? What,
Overview of Memcache?
Give us a sales pitch.
yeah, we've got some time.
Yeah,
You should actually.
full color brochure.
So I actually wrote this all into the wiki on. If you go to danga.com/memcached and click the wiki thing in the corner, you can see me rambling on for about 10, 15 pages. I wrote an architectural overview. So basically, Memcache is the simplest key value hash table as a server you can design. It doesn't get much simpler than that. What it is conceptually is a 2-layer hash table. So if you visualize how a hash table normally works, I'm probably not going to bother diagramming this. You have your list of keys and then your list of values, and when you want to look up a value, you specify the key. It does a hash operation on the key to find out where in your data structure your value is, and then gives that back to you. Now, Memcached, the server, isn't that clever. Internally, it's just a network daemon that listens on a port, and you say get value, and it gives you the value. You say set value, it sets the value. You have increment, decrement, add, replace, delete. You can set expire time. It's not that interesting. But what gets interesting is the client layer of Memcached is actually a second layer of hash table. So you have your client, which takes your key and hashes it out over your list of Memcache servers. So you can have one Memcached and it works okay. You can have 30 Memcached and it still works okay, because your key will just pick one random guy in the cluster and it'll work. And Memcached is, since it's fast enough, you don't really need to worry about load balancing in most conditions. There are a couple very extreme cases where, usually Facebook, where they end up with a couple Memcached which are getting 30,000, 60,000 queries per second, and everybody else is only getting 28,000 queries per second. They get very frustrated at that. But basically, what it does is allows you to take your results of anything you have in your application, either your query results or your parsed object results, your user object that you doled up all nice and pretty, or your actual HTML result. You can stick that in Memcache and get it back later. So the first time a user views their profile, you pull the profile data out of their database. You pull their birthday, you pull their bio page, you pull their friends tags, their IM info, all this junk out of 6 different databases that you have wherever. And then you compile it all together in a nice fancy HTML using their template, which you pulled from another database, and then did a whole bunch of processing on it. You pulled out their bad text and replaced their BB code, and have done a lot of work at this point. And at that point, you can take it and just shove it in Memcache and say, this expires after 15 minutes, or maybe an hour, or maybe a day, or whenever the user updates their bio at all next. So the next time the user comes in, it would go in and say, oh, well, their bio changed. We use this cache here, this cache key here, so we're just going to tell Memcache to update it or blow it away. So then the next time the user comes and views their profile, it just loads immediately, instantly. You just pull it on Memcache, it comes up, it's great and happy. So it's a wonderful tool. It does complicate things a little bit. You do need to mine your data. You can probably think it's somewhat similar to the MySQL query cache, which will just basically cache your, the results of a rows on a table. But the query cache gets, for an entire table, gets completely emptied every single time the table is updated. Because not Memcache, because MySQL has a hard time finding out if the cache queries were affected by an update. So it just blows the whole thing away. With Memcache, you can make that your decision. You can say, well, this user data, if they update their comment text, they don't need to see it for 30 seconds, so it doesn't matter, cache it for 30 seconds. Or when you know as the application developer that I've just updated this data, so then you, at that point, send it to Memcache. So the next time when the user updates their comment and then they click reload to go view it, you never have to hit the database. You just have to hit Memcache. And you can really do, you can build Memcache servers that are very cheap. You can put Memcached wherever you have free RAM. CPU usage is usually pretty low. It has a threaded mode now, thanks to Facebook, where you can run it on multiple CPUs if you're really hitting it that hard. Has a few interesting features, some interesting upcoming developments, but otherwise, it's pretty stable, pretty small, pretty compact product that usually does what you want it to.
Let's say you have 10 Memcached servers, and you bring up another one. Does that throw the client-side hashing off completely, and you basically...
So typically, right now, if you go and grab a random client, and set it up and do that, yes, your entire cache will become invalid, and you will have some factor of some mathematical algorithm, I forget, of having a chance of having your data be in the place that you think it will be. Which isn't so bad. You won't run out of memory on it, because Memcache is an LRU, a least recently used cache. So all items that aren't used will be pushed out in preference of new items, but you will temporarily lose most of your cache. There has been developments on the clients to use a technique called consistent hashing, which I can explain it in more detail if anyone's curious. But it means that I guess it adds an extra abstract layer of hashing. So that you have a third layer of hashing where you hash your server configs out into a hash table. And then you look up you hash your key onto this hash, which then points to your server, and then you can find your Memcached and find it. Basically what this means is if you add a new Memcached to your list and you have your secondary hash index, you're basically just adding it to this other index. You're not shifting everything around. So you have still a small chance of missing some of your caches, but when you add servers, remove servers using a client that supports consistent hashing, there's almost no problem at all.
The next problem you have, though, is as far as I know, none of the Memcached libraries, it's might have changed recently, none of the Memcached client libraries out there support dynamic reconfiguration of the pool, and certainly not atomically.
So the question is, do they support the dynamic reconfiguration of the pool, and what do you mean by that?
In other words, by atomically, I mean all of the clients simultaneously are updated with new pool information.
Not especially. That's not usually a big deal. If you're using consistent hashing and you're just adding a server.
Oh, it absolutely is necessary, because what if you do a write let's say that you do at T0 you do a write, okay? At T1 the pool configuration changes, and then at T2 you do a read. In that case, or I'm sorry, T2 you do another write, and then T3 you do a read, right? And you've got two servers in the pool that have completely different.
If you're using consistent hashing, you're going to get the same server back for that key anyway.
But the hashing changed at T1.
If you're using consistent hashing and you're adding a server, it doesn't disrupt your current list.
Yes, but if you have older servers, oh, I see what you're saying. Yeah. So in other words, what time?
You have a very small percentage chance of doing a cache miss in some cases, but with consistent hashing, if you add a server, it doesn't shift anything else around. So you can add servers and even remove servers, and if you remove a server, it'll cause cache misses, obviously. If you add a server, you'll start getting writes, new writes going to a different place. You probably won't. There might be still a case or two where that does happen. I can't figure that out in my head right now.
Is the consistent caching algorithm? I guess I'm concerned about any attempts to do perfect caching because there is no such thing, and two, as you add more servers in the pool, they may have different configurations. For example, I want to give twice the number. I want to assign twice the number of hash table or buckets to a server that has twice the memory.
Add it twice.
The easy answer is to not do that. But load balancing across multiple nodes at different capacity, what usually ends up happening is that you get the least common denominator out of every node in that pool. Algorithms, load balancing algorithms like these connections or doing waits on different nodes usually ends up in one node getting completely slammed and the other was not, because that was really hard to figure out. I would treat them all the same and get your lower end servers out of there as fast as possible.
Okay. Sometimes it's not always possible due to local configurations.
You can run multiple nodes on the server.
Yeah, you can. Yeah, it reminds me a lot of Meetup. We basically had a situation where there was 4 servers behind the load balancer. 2 of them were really old, 2 of them were really new, and we were experiencing a traffic spike. And the 2 new servers were handling fine, but since there was round robin load balancing across everything, every single machine got the same load, they're handling the same.
Right.
So the solution was to actually just drop the lowest 2 machines out of the bid, but let the 2 more powerful ones make that double connection. So what happened was the political part of it. I dropped the 2 slower ones out. The engineers saw that the 2 slower ones were out, so we're out of capacity. Put the 2 slower ones back in, increase the capacity, which caused the site crash. Sometimes it's just better to leave the slower guys out.
It definitely depends on how big the difference is. If they're 1/4 the speed. Yeah, as far as load balancing, if you're trying to load balance memcache, there's usually something wrong. If you have a server that has twice as much RAM in it and the CPU usage is not what you're concerned about, you can add the server twice. So you can add it twice to the consistent hashing list and it'll just get hit twice as often. Probably not a good idea if you can avoid it for obvious reasons that Eric listed. If you're trying to load balance it in any other way, trying to put an L4 in front of it, you're kind of defeating the purpose. Right. Well, I'm just saying that for completeness, I guess.
And is this in the current release? This is
well, the clients aren't bundled with the server. The clients are not bundled with the server.
Right.
So you can get, if you're using, what language are you using?
Depends on the day. So let's say PHP and Python.
Python, no. PHP, yes. PHP has 2 or 3 different clients. There's libkatama, which you use in front of any other client. Libkatama was written by last.fm. And it implements, I think it was actually the first non-Perl implementation of consistent hashing for memcache. Well, it started as Perl. So the example is one Brad Fitzpatrick wrote the CPAN module set consistent hash. So it's just a generic consistent hash module that you can use with the Perl client to implement consistent hashing. It's a lot simpler than it sounds saying it out once you actually go look at the Perl module. There's also another PHP class that uses it, and I think APR memcache, the C library, has an implementation of it. If not, it's on the way.
And you can plug in any hash you want, right, to the client.
Oh yeah, you can do whatever the hell you want to balance your lists. The Perl, for one example, with the Perl client, if you have, say, 70 memcache servers or 70 memcache instances, like I have before, and you have user data that you all want to fetch. So you have user data of the user's birthday and their name and some of their URLs and some other information, and then 10 unique data entries, like the 10 blog posts by a user. And if you're just normally using memcache and you're storing each of those 10 blog entries in, they could end up on different memcache servers. Now, when you're trying to read your data back, you have to go get from one, get from the other, get from the other, get from the other. There are two things you can do to deal with that. One is clients which use non-blocking I/O, so they'll actually send all the requests out and then read them slowly. The other thing is, at least in the Perl client, you can define your own hash value for a key that you're giving. So you say, if this user is user ID 10, I'm going to say this hash value for this keys, for all these keys that I'm storing for this user are user :10. So that'll make sure that all the data for that one user will tend to end up on one single server. And then you can use a get multi. You send one request down to memcache with saying I need 10 keys, and it'll just stream it all back. It's really fast. So that makes that a lot easier.
What's the overhead? I need n bytes for my key and value, how much extra?
So what's the overhead of using it? Less than querying MySQL?
It's really tiny if you were to wire program.
It's very, very, very small. Usually it's just the latency of your network.
What about memory usage
A couple hundred bytes.
per record?
So the value, when you're storing a value in memcache, you're asking for the memory overhead. So the way memcache stores your actual data is using a slab cacher. So it breaks up, you might have a gigabyte of memory in memcache, but that's actually broken up into a power of n different classes of slabs. The largest being a megabyte, the smallest being, I think, 100-something bytes. Your average is going to be about 100-something bytes or less than 2 kilobytes. So what happens is, as you allocate memory, you end up, it allocates these slabs. And the slabs are created like maybe 100 bytes, 125 bytes, 150 bytes, 200 bytes, 250, 400, 700, 900, a kilobyte, and that way up. So when you store a value, it'll pick it'll pick the slab class that's closest to the size of your data. So you will have a little bit of overhead. When Stephen Grimm from Facebook got to that and redid the slabber a little bit, he really lowered the amount of overhead you have there. But you do lose a little bit of memory. But I guess the idea is that RAM is cheap and you can actually tune that value. So if you know that your data is always going to be less than 2 kilobytes, you can set your max down. You can adjust the power of the slabs and say, I know all of my data, or I'm going to have 4 million objects that are exactly 100 bytes. So I'm going to make sure that most of my values are in that range. And you'll get very little overhead. Any other questions?
How does tree cache compare with your cache?
How does what?
How does tree cache? JBoss has this tree cache, tree structure.
3 cache? I'm not sure offhand. Any other?
It's written in Java, it's going to be way slower.
Besides that,
Is it EH cache?
basically they let you store an object tree, so you can invalidate the node in a tree. So.
I might have seen this. Obviously, once you get anything more complex in memcache, it's going to be a little more work. Also, when you're storing Java objects, you have to implement serializable. And in all these cases with memcache, you have to be able to serialize your object. If you're really careful about it, they're probably pretty similar. But memcache is very much, I guess, tuned for batch processing. Single connection can handle a stream of results or queries that comes in, stream out results. So it's very tuned for very, very quick, tiny little accesses, and you don't really have to worry about storing trees, or you don't have to worry about storing access lists and this and that. There's some development for adding more complex data types into memcache, but it's being done very carefully so that we continue to scale ON or O1 with whatever you're putting in. And in most of the cases, if you want to store some kind of complex data object into memcached, you can do a number of things actually on the wiki as examples for storing in. What's the best example? I don't have a good example off the top of my head. You could store in. You have like a tertiary key that describes list items that are keys for other objects that you want. So if you want to store a list, you store your list in one key, and then you get that, you fetch that. So you do one back and forth, and then you get the rest of your keys and you pull it out, and you just update that tertiary key when you're updating your list. So there's different ways you can store any kind of data, even though memcache is perfectly flat. Anything else?
How robust is the UDP client server?
UDP, Facebook says it works okay.
Do you know what size it starts to make sense to use TCP instead?
Anything above the MTU of your box, 14, anything above 1,400 bytes, and well,
TCP setup teardown takes time.
usually if you're using memcache, you might as well use persistent connections. You can have 20, 30, 40, 50, 60,000 connections against memcache, and you'll only waste a little bit of memory. It won't actually slow it down at all. Because the memcache is only going to respond to connections that are active with data. So if you have a connection that's just sitting there idling, it's just wasted memory.
Yeah, but if you've got Apache run into it, run a PHP instance, you're not going to get any persistence.
Right, so in the Apache PHP case, and you can't use persistent connections, Facebook they say they get a really big performance boost by using UDP for certain objects. So if it doesn't matter as much if you lose it, you're probably not going to lose it if you're on a LAN. But if it doesn't matter as much, you will get a pretty marked performance increase. I wish they would have benchmarked it. I haven't tested it myself yet, but they say it's pretty quick.
Does anyone have any kind of proxy that you could put in front of memcache? Like a local socket or something?
Facebook wrote one. They said it was embarrassingly slow, so they never released it. It's just a generic proxy, and you can connect to it through a Unix socket. You connect to it through TCP. I don't know. So the question is, using shared memory, mmap files. Usually, if you're in a situation where you can use mmap to talk to your cache, you have a much faster local cache already.
I'm just thinking of using machines like a back and forth between a local proxy TCP connections to memcache. So you would have the TCP session already open and communicate with your machine is way too fast and simple. So.
You could do that. I don't know of anything that does that. Of course, something like the MySQL proxy or my proxy, you could pretty easily plug in APR memcache into that and use, I think for most languages, persistent connections to MySQL work okay. So you could have special commands, like memcache get, that passes through the proxy that actually just talks to memcache through a persistent connection. Anything else? Anything clever?
That seems to me if you're writing a proxy for it, you're just sort of shifting the bubble.
Well, it's still being able to use TCP, yeah, not have the overhead of tearing up and down this all the time.
Right, but you're just shifting the problem from one layer to the next, right? Because you're instead of having all the clients connect directly to memcache, now they're connecting to a proxy instead.
Yeah, but not
Shared memory just on the proxy.
yeah, shared memory is a lot faster. than
Per box proxy is what
Yeah,
you're saying.
exactly.
Oh, okay.
And then
Yeah.
using a local socket. Very short.
That makes sense. I got you.
Anything else? I don't know how we're doing on time.
Let's run PHP using AskGui.
Huh?
That's 8:30, so.
Oh.
I don't know. Just like 8:30.
It's 8:30, about there.
What was the domain name of the wiki?
You go to danga.com,
Danga?
danga.com, and it'll be linked on the front page. Anything else? Last call? Okay.